My guest today, all the way from Cape Canaveral, Florida, is Jim Fletcher. Jim is the CEO and founder of CPI Technologies, and we actually see an illustration of some of that technology behind him on the large mural. And we're going to talk about CPI, solar energy, and my Quikbyke startup. So I'm going to share people a little bit of background about the crazy stuff I'm involved with and how we're looking to maybe use some of Jim's technology. So Jim, welcome to EV World.
Well, thank you, Bill. Thank you for inviting us and giving us this opportunity.
Well, good. I hope the Erica has blown through and not given you a lot of too much trouble there.
No, it's been a little rain, but other than that, we haven't had much problems.
All right, great. Very good. Well, look, let's start off by just having you tell us who in the world is CPI Technologies?
Okay, we're a small veteran-owned business, obviously for technology purposes and creating prototype hardware primarily early on and developing somewhat from scratch, but based on a technology that was developed at Kennedy Space Center, partially developed there. It was actually developed by a third party and then further enhanced at Kennedy Space Center through a partnership, or it's not a partnership, I'm sorry, a teaming arrangement between a small business called MEI, Merrifield Engineering Incorporated up in Tennessee.
Oh, okay.
The original patent holder on the on the technology would be a good way to say it, and kind of a teaming arrangement with him to develop that technology for applications at Kennedy Space Center.
Okay, so your role in all of this then, obviously you're, from our previous conversations, you've been involved as a NASA contractor for quite a while, you and your compatriot lurking off camera there.
Yeah,
Dave Manderick. You guys have been involved with NASA, so give us a little bit of your background.
Okay, I'm old, as you can see, number one, so I've been around a while, and matter of fact, I'm going to tell you one little quick story. I don't know if you want to keep this in the interview or not, but I was told when I graduated from college and at Georgia Tech back in the 70s, early 70s, into the Apollo program, they were giving some advice. Said there are only two types of aerospace engineers: those that have been laid off and those that are going to be laid off.
Yeah.
Having said that, it took 37 years before I ever got laid off, but we finally had a layoff at the end of the shuttle program.
Right.
So that's kind of the essence of why CPI Technologies came to being, but it had to do with the fact that I've always wanted to have my own business, but working for Lockheed and eventually two different Lockheed companies, and then eventually for United Space Alliance, which was a partnership between Lockheed and Boeing. They just treated me so well, it was hard to make the breakaway and go do it on my own. And so I forgot where we were going with the question, but I did want to give you a little background there. But I'm an aerospace engineer by degree.
Okay.
And worked with Lockheed Missiles and Space back in the mid to late 70s after getting out of the Navy. And got a bachelor's degree, went in the Navy, 5.5 years, flew P-3s, that kind of thing, chased submarines around the North Atlantic.
Right.
And went back to Georgia Tech because I felt I never got to practice any engineering, so I went back to school to get a master's degree. And at that time, the first oil embargo had happened in 1973.
Yeah.
Having oil prices up, and of course it was very sensitive to, it was on my mind and others, and already been thinking about solar and other ways to, to try to improve the oil situation or the electricity and other energy needs situation. So went back to Tech, got my master's degree, and Tech at the time happened to be one of the leading universities in the United States doing research in solar energy.
Okay.
Got involved in some of the very early solar projects back in the 76 timeframe, I guess it was. Actually involved in the Carter administration's booth for his inauguration, was involved in that, and also the first heated and cooled elementary school in the nation, Towns Elementary School.
Oh, okay.
And so a little bit of background there, and did some basic research on solar ponds and solar tracking systems. A lot of varied background, but the majority of that background was not in electrical PV. It was in thermal, so it was a basic thermal background.
Right.
And got a job with Lockheed not too long after that. Started in January of '77. So I'm not going to give you the whole history.
Right.
Did energy research for about 7 years. worked my way from like a research assistant all the way up to actually the program manager for all the energy systems work for Lockheed Missiles, not in the whole company, but at the work in Lockheed Huntsville.
Okay.
Research and Engineering Center. So I had that, and then and at the end of the Carter regime there, all the energy money basically dried up. Department of Energy money dried up doing all the demonstrations they were doing, and Lockheed made a decision to kind of get out of that research field for a while. And they gave me an option. One was to look at the Hubble program, working on it. They're in Marshall area, and or going and helping them out down at the space program in Kennedy Space Center to help transition the workforce. So I actually came down here on loan to help transition the workforce from from Rockwell to Lockheed. And then they made me an offer that was too good to refuse, so I stayed.
Okay, so you were with the shuttle program from when till when then?
Well, from 83, actually officially 84, I guess, because we didn't take over the contract till I think it was February of 84.
Okay.
But I came down in 83, so from 84, say, through 2011.
Okay, and so you got to see quite a few of the launches, I assume, and recoveries and all that kind of cool stuff then.
Yeah, it is a pretty cool place to work.
Yeah. All right, so how did you then get involved with, and we're going to talk here in a moment about what this technology is, but how did you get involved with that then? What has become your truss technology?
Okay. I actually was in engineering management, operations management, and then engineering management for a good bit of my career down at Kennedy Space Center. But toward the end, after the Challenger accident in '86, and then later on with Columbia accident, some of the layoffs and stuff, some of the organizations started shrinking, and the department I was managing got very small in numbers, so they did some consolidation. Right. And I actually went back to, as a staff engineer, if you will, on staff to the director of design engineering for all the ground support equipment and facilities at Kennedy Space Center.
Okay.
And as part of that duty, we were always looking for ways to improve the process, of course, and try to make it not only safer but more efficient, saving money, that kind of thing. And one of the things that I was looking at personally, fortunately my boss gave me quite a bit of freedom as to what I wanted to work on and pursue. One of the things that we're looking at, it was a way to improve access to the vehicle, the orbiter or the shuttle, at the pad or at the OPF or VAB, wherever. But there have been incidents in the past where things had happened, broken, or something had gotten lodged or whatever around the vehicle, or something they needed to inspect, and there were no access platforms to that area.
Yeah.
So I started looking at truss technology as a way, and I should say deployable truss technology as a way of accessing areas that aren't designed into the system at the time. Right. They were not; those capabilities weren't there. And in some cases, they had to roll the orbiter all the way back. The shuttle, I should say, all the way back to the vehicle assembly building just to get an access to an area to work on.
Oh, yeah.
Those came at great cost to the program as well as to USA or Lockheed, whoever was involved at the time.
Yeah. So that would obviously not only just time, but also, money, but also the time that it took, that it ate into launch schedules and things like that then. Absolutely.
Unfortunately, a lot of times when it happened, of course, at the pad, there was not a lot of reaction time. You couldn't make up for that loss very easily. So it was almost always a direct impact to launch date when that happened.
Right. Okay, so let's talk about this truss technology then that you took and adapted. I gather you saw this company in Tennessee had developed this, and you said, maybe we could use that to build a extendable, I guess the best word is extendable bridge across the shuttle bay, the cargo bay, so that we can have access to these things that we've had difficulty getting to in the past.
Right. Actually, it was almost that way, but in reality, I'll try to give you the short version of this, but in an attempt to try to get to something at the pad, I basically was looking for something with a high compaction ratio so that you could put it in an elevator and take it up to whatever level you needed on the pad, roll it out to some pre-designed attach point on the outside of the structure, and then attach it easily. It had to be lightweight, it had to be extendable, and it had to be able to support a person, or at least at the very minimum, or some kind of robotic arm on the end to retrieve whatever you're trying to retrieve.
Right.
A camera or whatever. And having to do, so we looked at this technology potentially as that, and actually USA, it wasn't funded by NASA, it was actually funded by the United Space Alliance as it was actually their very first independent research and development program. And in conjunction with this company out of Tennessee, negotiated a field of use for that hardware in the space field, for both the ground and on orbit, potentially. That was there. And so in that teaming arrangement, we went and started developing it for access platforms, primarily as a people platform, and tried to pitch it to get permission to put it at the pad.
Yeah.
And that's very difficult in this environment when you're working around a $2 billion vehicle. And you're sticking this thing out into, you can imagine if you're sticking it out into the wind, within inches of the vehicle, everybody's concerned that you're going to have a major catastrophe.
Yeah.
So as a result, no one was willing to take that risk early on. And quite frankly, there was no real need to do it at that point because there hadn't been anything at that time frame. By the time we had developed that, there was nothing that was happening to get anybody too excited about the need anymore.
Right.
So I started looking at applications where we could really improve just the process itself. And we were very fortunate, I might add, by finding the one that we did find, which was accessing what's called the 1307 bulkhead, which is the aft bulkhead of the payload bay itself. And there was a particular setup there that required a lot of manpower, and I won't get into the numbers, but a lot of manpower and a lot of hours, and that setup happened on average 3 to 5 times per processing flow. So for each orbital processing facility, 3 vehicles and 3 facilities, it could happen, 15 times a year at least or more.
Yeah.
So it was quite a savings to be able to provide a solution. In this case, we could do it in about 20 minutes with 2 guys with this new technology. And it replaced a significant number of man hours for that application. So it was an easy sell, if I can say it that way.
Right.
The hardest part, of course, was going through the engineering and getting the team to make sure that all the I's were dotted and the T's were crossed to make sure we got permission to lift this thing and suspend it above this very expensive orbiter.
Right, exactly. And I've seen the photograph you showed me, but just for people that haven't had a chance to see that. So what we're talking about is if you imagine standing over the top of the shuttle looking down, and the cargo bay doors are open and folded back, you're on the very back bulkhead of that cargo bay, just where the vertical fin starts to come out of the aircraft, and also you've got those 2 rocket engine nacelles that are coming off the back of that as well.
Those are actually called the ALMS pods, the Orbital Maneuvering System pods, and they're right, as you said, to the left and right of the vertical stabilizer.
Right.
And you're exactly right. We were there, and there was actually some flip down and some slide out type platforms on either side of the payload bay, like you said, with the doors open, so you can get fairly close to the area, but there's nothing to span across there. So in fact, the program was actually using typical construction scaffolding and using some very skilled workers to tie these things off and to clamp them together and to tie them off. And in an aerospace age, it made a lot of people nervous, being around this vehicle with clamps and that type of thing.
Yeah.
Even though it wasn't a very long fall, you could damage some very, very sensitive equipment and that type of thing. And of course, someone could have
got hurt, seriously hurt. Yeah, because that thing stands. I mean, I was close to the original Enterprise. Back when they were doing the free fall tests out at Edwards. So I have a sense of the size, about the size of a DC-9, and I spent quite a few years in my airline career playing around DC-9, so I have a sense of the size of those things. So
yeah, I happened to be, when that was all happening, matter of fact, I remember the Enterprise after that test, I believe it was after the test, was brought through Marshall Space Flight Center and got a chance to see it on display out at Marshall.
Yeah, absolutely.